Good morning, ladies and gentlemen. Today we're looking at the chain rule. Now, the chain rule is probably the most important rule in calculus. It is used all the time when we have composite functions. So composite functions is where there's one function essentially nestled inside another. And you'll have looked at this briefly last year. So for example, if you have g, this here is pronounced g of f of x. That's come from a g of x and an f of x. And what that's saying is that here, instead of just an ordinary x going into the g function, this entire thing is going into the e function in place of where we'd normally see an x. So here, that's saying that, well, the g function reads x to the power of 4. But we're not putting an x into the g function. What we're doing is we're putting f of x into the g function. So g of f of x looks like this. 2x takes 7 to the power of 4. Essentially, the inner function is 2x takes 7, and the outer one is x to the power of 4. So we're thinking outer, inner. Here, outer, inner. Alright, so here, if f of x is the inner function, it will go inside g of x. So basically, where f of x will go where x is inside g of x. So sine x cubed take 3x plus 4 will be the composite function. Or here, f of x goes inside g of x again, so it will be 1 on sine x. In reverse now, given a function, we want to try and split it into an inner function and an outer function. The inner function in calculus we often call u. Here the inner function would be x squared take 4, and that's been thrown inside a sine x function. Or what we can say is that we call it sine u. So sine u, where u is equal to x squared take 4. Or this case here, u will be equal to 2x cubed minus x plus 3, and the outer function is just root u, square root of u. Square root of u combined with this polynomial creates that. This one here is a little harder, but hopefully you can see the entire thing is being squared, so it's u squared there, and the inside function is cos squared x minus 3x. Or here, the inside function is 6x squared take x plus 2, and the outer one is log x, or log u. Alright, how does this help us? Once we get good at recognizing inner and outer functions, how does this help us with calculus? Well, if you have a function that's nested, so g of u, g being the outside and inner function, then you can differentiate it by doing g dash u multiplied by u dash, or g dash u multiplied by f dash x. Those two are interchangeable. Or that's the book's fancy notation, which really is painful to watch. I realize that chain rule explanation makes no sense right now. I think it's better seen through examples. Alright, here, whenever you see an inner and outer function, I would honestly write them as inner and outer. Inner, outer. Sorry, I like them the other way around. Outer, inner. Here, the outer function is u to the 99. And the inner function, where that there is u, the inner function is x squared take 5x plus 2. Alright, so to find f dash of x, what we do is we do the derivative of the outer, which would be 99u to the 98, multiplied by the derivative of the inner. The derivative of the inner is going to be 2x take 5. Alright, And then right at the end, we remember to change the u back again. So here, our u is the inner function, so it becomes 99 x squared take 5x plus 2 to the 98 multiplied by 2x take 5. And you would not be expected to expand and simplify. Essentially, it is the outer is differentiated, multiplied by the differential of the inner, and then just remembering that you can't leave it as u, you must sub the inner back in. So that there goes in there. All right. More examples. Here, outer. You don't have to write outer every time, but the outer is the square root of u. Inner is 3x squared plus 4. So, f dash x is the derivative of the outer, which is a half u to the minus a half, multiplied by the derivative of the inner, which is just going to be 6x. Right, and then we have to remember to replace the u with what it was initially. So it's a half times 3x squared plus 4 to the minus a half times 6x. And if we don't like writing that with a negative exponent, we can write that as 6x over 2 3x squared plus 4 to the power of positive a half, which is the same as a square root. But what we've done is the inner and outer, differentiate the inner, then multiply by the differential of the outer. Or, the way I really liked to see it on the internet, which I found quite amusing, was really here the inner function is just something. So what we do is we differentiate the something. The 3 goes to a 2, 3 comes out the front and makes a 15, and then that is multiplied by the differentiated something with respect to x. So the way you would do this easily gets you down to there. Now note that, yes, you could expand and simplify and solve just like an ordinary polynomial, but it takes too much time. And also it doesn't work when we use sine and cosine and logs later on, so you must learn to use the chain rule for these. Alright, here's a harder one. The outer function is going to be equal to 3 over u to the third, and the inner is going to be equal to 2 take x to the 4. Alright, and remember that's 3u to the minus a third. 3u to the minus a third, if we're going to differentiate, the power drops down 1, power comes down the front, 3 times minus a third is minus 1, u to the minus 4 on 3. And that then is multiplied by here, which is just going to be minus 3x to the 3. Then sub back in, minus 2 take x to the 4 to the minus 4 on 3 multiplied by minus 3x3. And you're not expected to take it beyond that. If you wanted to, you could drop both the negatives, but honestly that's fine. The important thing is you differentiate the outer and then multiply it by the differential of the inner. Alright, check your understanding. Have a go with these two, and hopefully you come out with them. I think chain rule is the hardest thing to master. Once you get it, it really does just flow off beautifully. Have a shot at them. I'll see you next lesson when we'll do plenty and plenty of practice.